Our project is on lake stratification. My name is Jacob Welch.
And I'm Julissa Lowe. So lake stratification is a natural phenomenon that occurs in locations where the winters are extremely cold and the summers are extremely warm. So in the wintertime, lakes will freeze over, but underneath that ice is water, and it's warm water, and this is partially why fish can survive through winter. And then during the summertime, when you're swimming on top of a lake, it feels nice and warm, but as soon as you dive down, you can feel a drastic change in the temperature. And this is because the lake is stratified in the summertime, meaning that the temperature changes as the depth changes. And there are thermoclines in the summertime, which is basically with each changing layer or depth in the lake, the temperature changes. And the section where the temperature changes the most is the thermocline, because it has the greatest temperature gradient.
And this lake stratification occurs a great deal based on water density. Now, water density changes due to the change of water temperature. The water is the most dense at 4 degrees Celsius. This is also known as absolute density, and it maintains this absolute density from 4 degrees Celsius all the way down until it freezes at 0 degrees Celsius. Once water is frozen, there's a different molecular structure which causes it to be less dense. One of our main purposes was to understand how the ambient air would affect the water temperature. The ambient air temperature would affect the water temperature, which temperature affects water density. And we understand absolute water density. We also wanted to see this through experiment and through calculation.
So water density, we have the following equation that everyone knows: density is equal to mass over volume. And we have a picture as an example. So in each of these containers is the same amount of water. One is heated, one is at room temperature, one is chilled. So the heated container, the molecules in there receive more energy from the heat. And in turn, because they're warmer, they bounce off of each other, and they get further apart, causing more volume to be taken up. And so the warmer they are, the more volume they take up. And the opposite occurs with cold, chilled water, where the molecules are drawn closer together to conserve that energy.
As we can see in these three pictures of a gas, a liquid, and a solid, there are the same number of molecules. The only thing that is changing is the temperature and then the volume that those molecules take up. So the very bottom example, as the temperature increases, the volume then also increases. Using the equation of density equals mass over volume, this would cause the density to decrease.
So absolute density is very important with lake stratification. It's kind of a difficult concept to understand, but I think it's easiest to compare it to terminal velocity. We all know that terminal velocity occurs when an object is falling through the air and it reaches the maximum velocity it can reach, so it can't go any faster. So this is kind of a same concept to absolute density, where these water molecules are so close together and packed together that they are at the most dense state that they can be in. And so this occurs at 4 degrees Celsius and continues all the way until it is at 0 degrees Celsius and forms into ice. And in the ice form, the molecules are spread out in such a way that it causes them to be much less dense than its absolute density. The bottom of the lakes in each of the seasons is at 4 degrees Celsius, and this is because 4 degrees Celsius is the maximum density. And then in the summertime, the water is warmer on top, and in the winter, the ice is on the top, but the most dense water is still on the bottom.
So as this video loads, I'll just talk about it. We want to prove the density of water. In this video, there will be blue cold water and red hot water. As the cold water on the left, the cold water is on top, it is more dense, so it wants to mix with the hot water on bottom. Now on the right, the hot water is on top and it is less dense, so it will stay there and there will be no mixing. We need to understand this concept for lake stratification.
So for our experiment, we wanted to be able to simulate lake stratification, but on a much smaller scale. So in order to do this, we purchased 2 totes and some packing peanuts. And we filled the smaller tote with water, and we measured each gallon mark and marked it out. And then we took that tote, placed it inside the larger one with the packing peanuts. And then for the winter simulation, we put that in a freezer, and we recorded the temperature at the different depths every half an hour for about 3 hours. And then we did the same thing for the summer, except we put the totes in a warm room. And then for the spring and fall, we used a hairdryer to simulate the wind velocity that would occur naturally in nature. So for winter and for summer, free or natural convection occurs. And we use the related new salt correlations in order to calculate our new salt numbers.
And in the spring and in the fall, we introduced an air velocity. So we need to do the grass hop over the Reynolds squared to see if it was forced or free. It was just forced convection. So then we used the appropriate new salt correlation to find an H value. And with that H value, we did calculations to determine the heat transfer occurring.
So for our results, the wintertime had the greatest heat transfer in the middle. And this is because the bottom was not as well insulated as it should have been. But because the bottom and the top were not quite perfectly insulated, the bottom and top both drew heat away from the middle. And so the top layer is the layer that became ice, and the bottom just stayed at the 4 degrees Celsius. And then for the summertime, because the ambient air was warmer than the top of the surface, it withdrew in heat, and the same occurred for the bottom.
Absolute density is essential in lake stratification, meaning the bottom of the lake contains the most dense water, not necessarily the coldest. This was seen in experiment and calculation.
We came to understand that heat transfer is greatly dependent on the ambient air temperature and insulation. One thing we would improve is the precision of each depth at which the temperature was taken.